These aren't the droids we're looking for. Okay, no, but seriously, I'm here to talk to you a little bit about my BB8 Quadcopter project. And the idea is it'll be, BB8 ball, dome top. The head will just balance on top of the ball. The ball itself will actually be the drive. It'll have a heavy weight in the bottom that drives up the sides of the wall to roll the ball, and the head will just keep on top or move to the sides, look around. And its main feature is going to be that it has quadcopter motors that come out of these rings in the sides, and it can fly. I just want to give a shout out to James Bruton. If you haven't checked out his videos, you should. They're epic. I'll leave a link in the description. But it was really his two droids, his R6 and his BB8, which was a dome that bounced on a ball and could tilt sideways to make it roll in a particular direction, that made me think to do this. Now, the first thing was his R6 was printed from ABS. It's amazing how strong the solvent welds are. This helmet's my first big ABS project, printed in 15 pieces, solvent welded together, and it's really tough. And this ABS really punches above its weight in terms of strength when it's done with the infill, strength for weight. So hopefully we'll be able to make a light enough frame that the BB8 can fly. So now let's go look at some of the CAD drawings I have done, and we can see some of the testing I've done on the quadcopter motors I have. Per blade widths, deployment mechanisms. Should be pretty interesting. Okay, so you can see my first design in this little animation I've done. You got a nice deployment of the propellers and the motor, and then it latches in place. If you see the little red latch pushing, the servo pushes that into place to lock it out. And here's a SCAD file for all that. You can see the body frame. It's made of two spheres, one bigger than the other. The main drive system goes in the center sphere, and all the gadgetry, including the quadcopter motors, fit in the outside. And little covers actuated by servos. It's not designed in yet, but this is the design right now. However, I did some testing with this prop diameter, and it's not going to fly. Pun intended. So, let me show you those tests real quick. In this first test, you see the 10 by 8 inch propeller produces a considerable amount of thrust with its motor at full power, 4.5 kilograms. Now, for the second test, I used 6-bladed propeller. It's technically 2 3-bladed props, and it spins up to 9,000 RPM I measured at full power, but the thrust we get is only about 1.2 kilograms. So it's looking like we'd have to spin up about 15,000 RPMs to get the necessary lift. And we can't do that because of the huge loss of efficiency at those speeds. So we're definitely going to have to find a way to fit a bigger propeller into the system. Just a quick note on the test assembly. In the video you saw there was a large block of wood obscuring the propeller, but the force data is from a test with this picture jig where I cut out the extra airstream disruption. So we get 1.2 kilograms in this configuration. This test jig is pretty simple. It's just a lever. You calculate the thrust by comparing the lever lengths of the motor to the lever length of the force on the scale, which has been zeroed out. And there's a certain amount of torque, and I measured the angles and the lever lengths, and I calculate the thrust from the values on the scale. So here we have my second mechanism. It's a lot simpler deployment-wise compared to the other one. No slide, it just lifts out once the doors open. Now the trick with this one is how to get the propellers back in, because to fit they have to be folded. So what I'm trying to do is I'm going to try and drive the brushless motor like a stepper. And hopefully we can control the angle of the blades well enough to push them against the door to get them into a folded position and then drop them in. Alright, that's all for today. Thanks for watching. I'm going to try and put a video out every 2 weeks on this project, so keep an eye out. I'm having some 17-inch DJI folding props come in this week, so next video I should be characterizing those, making sure they can get the thrust, and hopefully designing the electronic speed control to step the motor, so we can see if we can actually fold those on the door for stowing it back away after a flight. So that should be pretty exciting. Thanks for watching.